Good morning, everyone. Welcome, everyone. Are you getting my voice neatly? Please make comment in chat box. Are you getting? बंद झाली. आता इथलं माझं लावलं नेट सरळ काय कटकट आहे यार. नेहमी काहीतरी प्रॉब्लेम येतो. Good morning, students. Hello, everybody. Are you getting the video and audio? If yes, comment in the chat box. So I will start the meeting. Should I start? Let us continue. Today, on 16th of March, we are starting with new chapter number 14. Semiconductors. Earlier, while discussing the contents from chapter 11, we studied electric conduction properties of conducting materials, conducting medium. In our normal life, we use different electrical appliances or gadgets which work on the principle of conduction of conducting material. But nowadays, in modern life, from 1947 onwards, we are also dependent on electronic gadgets. After the discovery of semiconducting materials, in electronic gadgets, semiconducting materials are used for conduction of electricity. So, we will proceed further to study and to observe the conduction through semiconducting materials. It is chapter 14. Open page number 242. It starts from page number 242 from the textbook. So I appeal all of you to open textbook and get page number 242. In this chapter, we will discuss electric conduction through semiconducting materials. These semiconducting materials have few particular features. So first we will discuss about features of semiconducting materials. Point number 1. Electric properties of these materials are different from conductors as well as insulators. Second important feature of semiconducting materials is in semiconducting materials transport of both type of charges. You know, one electrons and absence of electrons is considered as positive charge and is termed as hole. So here conduction is due to both type of transportation of charges, transportation of electrons as well as transportations of holes, or in few semiconducting materials The electric conductivity is due to only any one type of these two charges. So this is the speciality of these semiconducting materials. Then number 3, their electric conductivity can be customized. You can control the number of flow of charges through semiconducting material as per your requirement. So third peculiar feature of semiconducting materials is electric conductivity through semiconducting materials can be customized. You can customize it. This property is neither observed in conductor nor in insulators, and hence this is most important feature of semiconducting material. The conductivity can be customized using two ways. Number 1, by changing its temperature. At absolute zero temperature, semiconductors behave as insulators. But if the temperature is increased, even at room temperature, their conductivity is not observed. But when temperature is sufficiently increased, semiconducting materials are able to conduct electricity through them. So this is the second, or this is the first type through which you can customize the conductivity in semiconducting material. The other way to customize the conductivity is the process of doping. So either by changing temperature or by making the process of doping, the conductivity of semiconducting materials can be customized, can be controlled as per our desired aspect. So this is the peculiar property of semiconductor. So to study the semiconductor electrical conductivity, first we will discuss the band theory. Band theory is very useful to study electric conduction through semiconducting material. And this theory is related with energy levels of valence electrons. So before starting band theory, to understand electric conduction through semiconductors, first we'll discuss the atomic structure and different energy levels occupied by electrons revolving round the nucleus. Each and every electron has specific energy level. So first we will study atomic structure and energy levels of different electrons in different permitted allowed orbits around the nucleus of the atom. Suppose you have one isolated atom, single atom. Then what happens? In single atom, at the center there is nucleus and electrons revolve in different permitted orbits. They cannot take any orbit. The orbits are permitted, the orbits are allowed. Different electrons revolving in different orbits have different energies associated with it. So energies of electrons revolving in first orbit, we have energy level for electrons revolving in second orbit and so on. So these energy levels of electrons in different orbits are fixed, and hence for single isolated atom you can represent these energy levels by drawing diagram. Let us consider energy level of first orbit. So this is called first energy level. This is for isolated atom. This is energy axis. Then energies occupied by or associated with electrons revolving in second orbit is called second energy level. Then you will get third energy level. These are the levels. Electrons in that particular orbit have fixed energy associated with it, and you can have such energy levels for isolated atom. But when these atoms club together to form a solid crystal, any solid crystal, then the energy levels of individual atom gets affected, because there are number of atoms, and for each atom there are large number of closely neighboring atoms. So these atoms or electrons in the orbits of different atoms interact, and energy levels of electrons, especially orbiting in far orbits from nucleus, get affected. In that case, what happens if you take two atoms? This is now crystal. This is the region of crystals. Atoms are very close to each other. So what happens here? Electrons get interacted with each other from different atoms. So even though electron in second atom is orbiting in third orbit, you select electron in first atom even orbiting in the same orbit, third orbit. So both these electrons from different atoms should possess same energy, that is of third energy level. But here what happens, even though they are similar, since they are under the influence of each other and also under the influence of other atoms nearby, their energy levels get affected. We never get two similar electrons having same energies associated. Billions of first orbit electrons from different atoms should ideally possess same energy, but due to interaction while formation of solid crystal, the energy levels get affected. The energy levels get affected for the electrons which are far away from nucleus. For the electrons lying near the nucleus, there is no much affection, and hence what happens, different electrons orbiting in given fixed orbit but associated with different atoms have slight different energies associated. Billions of first orbit electrons from different atoms differ from each other slightly in their energies, even though they are similar in nature, all they are in first orbit of each and every atom. But first orbit electron of atom A will differ slightly in energy with first orbit electron of atom B. Similarly, first orbit electrons atom C, D, and so on. So there is slight change in energy associated with similar electrons, even they are orbiting in given fixed orbit, and hence for crystal these energy levels we are for in same orbit, and we call it as energy band. So for crystal, you always draw or represent energy levels, energy states for different orbits in form of energy band. The group of sublevels of energies in one particular orbit, they form energy band. So this is first energy band, this is second energy band, this is third energy band. So instead of considering particular energy level, we consider the energy band. Number of electrons in first orbit from different atoms have different energy values. But the difference between energies of these electrons is very small. They are very close to each other and they form a group of sublevels. And such group is called energy band. So we get energy bands instead of energy discrete levels when we study crystal. So this is energy diagram for crystal solid. So in crystal solid, we consider energy band rather than energy discrete levels. So we'll proceed further with this. So these energy bands, these energy bands have critical range of energies. In an atom, this we have to concentrate on energy band for their valence electrons. Suppose one atom has atomic number 18, then you will get combination 2, 8, 8, and in last you will get 5 electrons. So this is called valence band. So topmost partially or completely filled energy band for the given material is called its valence band. This valence band may be partially filled like this or may be completely filled. The immediate next higher band, immediate after valence band, is called conduction band. So we'll proceed further with this now band theory. So here in crystal, suppose of any solid, it may be good conductor, it may be insulator, it may be semiconductor, we get energy band structure. So topmost partially or completely filled band is called valence band, and the electrons lying in valence band or valence electrons. The immediate next band just above the valence band in which we don't get any electron is called conduction band, and there is gap of energy in between these two for each and every solid material. This is called forbidden energy gap. Forbidden energy gap or simply energy gap or also band energy. So you get this forbidden gap, difference between energies of lowest level, lowest edge of conduction band and our topmost layer of valence band. For few materials, we don't get this energy band. Valence band and conduction bands are overlapped. This is for conductors, and hence valence band are free electrons. They can conduct because they lie in conduction band also. For semiconducting materials, this forbidden gap is very small. It is of the order 3 electron volt. I am talking about now semiconductors. We have discussed what is valence band, what is conduction band. We have discussed forbidden gap or forbidden energy gap or simply energy gap or band gap. For semiconducting materials, this forbidden energy is of the order nearly 3 electron volt. It is very small, of the order 10 raised to minus 19, and hence at absolute zero temperature there is no any free electron available in conduction band. All lie in valence band. Even at room temperature, few electrons lying in conduct valence band receive thermal energy, and hence they jump into conduction band, and these electrons then behave as free electrons. But at room temperature, the current due to these electrons is very small, negligible. No device can be designed for electric conduction of this semiconducting material. In case of insulators, this energy band gap is very large, and even with the absorption of thermal energy or energy supplied by some electric source, these electrons cannot jump in conduction band. So there is no any free electron available in conduction band, and at any high temperature or even after addition of impurities, insulators never conduct because the electrons in valence band are not able to drive themselves to move in conduction band. Once electron goes in conduction band, it is available for electric conduction. So in semiconducting materials, these electrons can easily jump and occupy conduction band. So this is most important feature of semiconductor. So as per your desired expectation, you keep the temperature of semiconductor absolute 0 degree. So that temperature is not sufficient to raise the electron in valence band into conduction band. So at absolute zero, even at room temperature, these electrons don't jump in conduction band, and hence there is no electric conduction at very low temperature up to room temperature. But as temperature is increased, electrons in valence band receive energy and are able to free themselves and to jump in conduction band. Once they go in conduction band, the conduction is possible. So the conductivity of semiconductors you can customize, you can control by selecting number of electrons which can go in conduction band. So this is the special of semiconducting materials. So this now we'll focus on the electric conduction in semiconductors only. So these are the basic properties, basic qualities. Now we'll proceed further to study the typical nature of semiconducting materials. These semiconducting materials are of different types. Few are called elemental semiconductors, few are compound semiconductors, and third is organic semiconductors. Out of these three, first one is very important. It is basic semiconductors, that is elementary semiconductor. And we'll first study the basic conductor, elemental conductor, semiconductor, and we will observe its electric properties. So these elemental semiconductors are again of two types. One is intrinsic and the other is extrinsic. So I have now moved on point number 14.4 on page 245. What I have discussed just now, right now, I have covered band theory, point number 14.3, which starts from page 243. Then we proceeded further to study energy bands in solid crystal. They have given example of sodium. So not necessarily every time should be sodium. Any solid crystal, the energy band is in nature is same. Then we studied about energy gap, and then we proceeded further to study the ability of valence electron to make themselves as free electrons and to jump into conduction band. We now concentrate to study electric properties of semiconducting materials. As I have told, three types: elementary, compound, organic. Out of three, elementary is most commonly used. So we'll proceed further to study electric properties of elemental semiconducting materials. Again, elemental can be divided into two: intrinsic and extrinsic. Extrinsic side type semiconductors are very good for electric conduction. The electric conduction properties of intrinsic are very weak. They are not advantageous, and don't use them in different electronic devices because they show poor electric conductivity. So we'll proceed further. So we'll first consider intrinsic semiconductor, and then we'll go further for extrinsic semiconductor. We'll study these properties of semiconducting materials in series of few further lectures, and we will try to complete the chapter in 4 to 5 lectures of series. So I am winding the meeting because the time is almost up. If any query, do post immediately in chat box so that I could answer the same. If you have any query about anything, about college, about exam, anything about practical, do post in chat. I will immediately read it and I will let you know. Yesterday, a few students have raised the hands. Meher, Sarthak Meher, the other was Neha. So didn't post any query in chat box again. So I appeal all the students, if you have any query, do post in the chat box. I just want to tell. So next time we'll continue to study electric properties of semiconductors by taking their types, intrinsic first followed by extrinsic. So thank you for joining the meet. I am just winding the meet for everyone. You have to continue for the next lecture. A few students are asking about the exam. So the schedule of the exam is not still declared, but you have to keep studying because immediately after completion of 12th standard HSC board exam, your exam will be scheduled. So be well prepared. So immediately you will have exam in May, down in May, because from 23rd of April, HSC board examination is being conducted. That will end by first week of May. And then for 11th standard, we will schedule the exam in mid of the May. You also have practical exam too. So for practical examination, we will have some demo of the practicals. Let us see how to manage it. If any other query, according I don't. You are asking for engineering and the subject choice. They have declared, but when they are going to implement it, from this year, from next year, or after 2 3 years, we are not knowing. So don't be under wrong impression. If you want to offer engineering, you can drop maths or you can drop physics. You have to study all these group subjects. So don't yet the they have not still implemented it state wise. So we are not knowing. So keep studying all these subjects. Any other? We are not knowing the nature of the exam. For 12th standard, the exam is being conducted offline. Means students have to come and have to give physically the exam paper in the college premise. So for you students also, the exam papers of annual will be might offline. You have to come to the college only for exam sake, from my point of information. So as I know the next notices, I will let you know. So thank you for joining the meet. Tomorrow we'll start with electric properties of intrinsic semiconductors followed by extrinsic. Thanking you all. I am closing the meet for all. Join the next lecture.